In this video, I want to talk about velocity and speed. We want to look at the motion from a bunny. The bunny starts at -4 meters. We can write it down like this. Position initially, xi equal -4 meters. The I subscript stands for initially. Now the bunny runs and it ends at 6 meters. So now we write down position finally, xf equals 6 meters. With these values, we can calculate the displacement to find out how many meters did the bunny run forward. The displacement is delta x equal 10 meters. But the bunny could have also run like this, and we would have the same values. We would have the same initial position, the same final position, and that means also we would have the same displacement, but that's not a problem. It's just something to know. Now we want to know how fast the bunny was. But that depends on how many seconds or minutes did it take the bunny to run from the initial position to the final position. So we have to know that time. So let's just make up a time and say it's 2.5 seconds. And now we can calculate the velocity. And the velocity is defined through v equal delta x over delta t, where the delta t is the time interval in which the bunny completed the displacement. When we plug in the values from before, we get for the velocity v equal delta x over delta t. Now we plug in the values and we get 4 meters per second. So assuming the bunny ran at a constant speed, it ran throughout the whole motion 4 meters per second, and then in 2.5 seconds it ran the 10 meters. But we could also have negative velocities, and for this we look at this example. Let's say the bunny starts initially at 5 meters and then it ran to the new position at -2 meters. So now we write down those coordinates, xi equal 5 meters, xf equal -2 meters. And also here we have to know a time. So we make up a new time. Let's say it took the bunny 2 seconds to run this path. And now we use the same formula from before. The definition of velocity is v equal delta x over delta t. And now we plug in, only that now we have different values, and it turns out that when we plug in the values as they are, we will get that the velocity is -3.5 meters per second. And that's the velocity. We have used the definition formula, and this came out of it. And this negative signum already shows us in which direction the bunny ran. Minus means the bunny ran in negative direction, and before we had a positive signum, that means the bunny ran in positive direction. So now let's talk about speed. The speed tells us how fast the bunny was running. I mean, you might say that, oh, the velocity already told us that as well, but the velocity told us a little bit more. The velocity told us how fast and in which direction it went. So before we found out that in this example, the bunny ran at -3.5 meters per second. That was the velocity. And because the velocity was negative, we knew the bunny ran to the left. And speed just talks about how fast it was. So in this case, the speed is 3.5 meters per second. So we dropped the signum, but then we wouldn't know in which direction it goes. The bottom formula there also shows us how we can calculate the speed. The speed is equal to the travel distance divided by the time. And that's what we are most interested in everyday life. We don't really care about in which direction did we drive, or is it north, west, because we would just drive forward and the street would even curve. And when we go on a street like this, we might still want to know what's our average speed. How can we calculate that speed from looking at the travel distance time? And that's what we actually do. We use the formula from before. We calculate the speed is equal the travel distance by the time. We don't care about the direction at all. Also, we don't even set up a coordinate system. It doesn't apply for our problem. And typically, we write it like this, that v equal to delta x divided by delta t, and we know that we only deal with positive values, that we don't have the direction information there, but this is just way shorter to write it down, and then the delta x is just the variable for the travel distance, and delta t is the variable for the time, how long it took us. Then we plug in the values, and then we can calculate our speed. And depending on what units we use, we will also have a speed unit. It could be maybe miles per hour, or if we use the SI units, it could also be in meter per second.